6.3a, vectors in a plane. Again, what's a vector? It's represented by an arrow with what? Direction and magnitude. Oh yeah. All right, now we're only going to be dealing with vectors in a plane. All right, it's not that thing that flies in the air. It's not boring. What does it mean to be a plane? It's two-dimensional. Very good. All right, so we're only going to be dealing with two-dimensional in this class. If you get to go on to further mathematics like Calc 3, it's not going to be just a plane. It's going to be three-dimensional, four-dimensional, even five-dimensional. All right? I agree. Once they got to 5 dimensions, I got kind of pissed too, bro. All right, so here we go. So it's a directed line segment represented by an arrow. All right? It goes from an initial point to a terminal point. That's the direction that it's going. All right? Anybody ever been to an airport? I know COVID season's happened, but like you guys been to an airport, hopefully, maybe? Yes. You start at an initial point, and guess where you go? You go to a terminal. That's the direction that you're going. All right, so when you write it, it's represented by an arrow. So I go from P to Q. It is not going from Q to P. You following me? All right, so that arrow does matter. All right, now, so it goes from an initial to a terminal with an arrow, and it has a magnitude. A magnitude is a length or a distance. So guess how you find magnitude or a length? The distance formula, exactly. All right. Now, there are different notations on finding a magnitude or denoting a magnitude. The most common used, and that's what we're going to be using, is it's kind of like a double absolute value bracket. It doesn't have to do with absolute value at all, but it kind of looks like a double absolute value bracket. So that's what means a magnitude or a length or a distance. All right. Pretty good. What's a vector?
Line.
Represented by an arrow that has what? Direction and magnitude. Oh yeah.
Why were you playing?
Thanks, Angela, for volunteering.
Let U be represented by the directed line segment from P 0, 0 to Q 3, 2, and let V be represented by the directed line segment from R 1, 2 to S 4, 4, as shown in figure 6.17. Show that U and V are equal.
All right, fantastic. So I'm going to do the vector PQ. And so when I notate PQ, it's represented by P, then Q, with an arrow over the Q. Why can it not be written QP? Okay, because then it'd be going the opposite way. All right, and what we're going to do is we're going to find its magnitude. All right, so we're going to notate it by finding its magnitude. And we find the magnitude by the distance formula. So it's the square root of the difference of my x's. So what's the difference of my x's? Not much, we broke up. What's the difference of my x's? 3. So now I have 3 squared plus, what's the difference of my y's? 2. So now I have 2 squared. All right, 3 squared is? 9. 2 squared is? So we add them together, we get square root 13. So my magnitude of PQ is square root 13. That's the distance, the length of that vector. All right, so let's do the same thing for RS. Can I call it SR? No, I can't. All right, I have to call it RS because that's the direction it's traveling. Now, I'm going to find the magnitude of that as well. So what's the difference of my x's? 3. So I have 3 squared plus, what's the difference of my y's? 2 squared. This is like deja vu. So what do we get? Square root of 13. So it looks like it's going in the same direction. And we also have the same magnitude. So we're going to say that those vectors are equivalent. Write notes however you want. So the first thing we're going to do is what's called a component form of a vector. All right, a component form of an vector is we have an initial and terminal points, but we find it by using these little chevrons. I also call them angle brackets. I didn't know they were called chevrons until I got married. All right, but it is actually a mathematical term that's actually used. I didn't know that. I always called them angle brackets. But to find our x value, we just do terminal minus the initial. All right, write this out. Terminal minus the initial. You're going to be using that often. I have it bolded here, star it, circle it. Put smiley faces by it, whatever leads you to it. So your terminal point minus your initial point will give you your component form of your vector. And you notate a vector by using those angle brackets or chevrons. They're not pure parentheses. Now, sometimes texts do use parentheses, and I despise it. All right, use some chevrons or angle brackets. All right, so all we have to do is we find our x value of our terminal minus our x value of our initial. We subtract them. That's what's happening there. All right, and then the same thing for our y value. All right, magnitude again is what? The distance formula, the difference of the x's, kind of. All right, plus the difference of your y's, both squared underneath the square root. Now, I want you to write this part out now. I want you to say when the magnitude is 1, it's called a unit vector. We're not going to be dealing with that today, but we will be dealing with it soon. If you have a magnitude of 1, if I have a length of 1 of a vector, it's called a unit vector. It will become important soon. Today, we're not going to get to it, but I'd like you to write it down eventually. Now, I don't care if you write this other part. I think it's stupid. If you have a magnitude of 0, it's called a 0 vector. Now, why is this not useful at all? What does it mean to be a 0 vector? There's no direction, true? It's just a point, exactly. There's no length on anything. So it's purely just a point, all right, which I don't see a point to it. All right, so. Thanks, Joseph. Hey. All right, so let's do this one. Kate, go ahead and read for us.
Find the component form of a vector u with the initial point -2, 5, and terminal point 3, 7.
All right, fantastic. So I need to find the component form of vector u. So they tell me I have to call this thing u. Well, I have where I started and where I went. And how do we find it? It's always what? Terminal minus the initial. Terminal minus the initial. So my terminal, my x value of it is what? 3. Minus the x value of my initial, which is -2. Comma, my y value of my terminal, where I ended up, is 7 minus 5. So, what would be my component form of this vector? 5, 2. Now, I want to talk about what this vector did. This 5 means it went to the right 5. Okay? What if it were -5? What would that mean? That means it would go left. This 2 means it did what? It goes up 2. If it were -2, it would go down 2. All right? All right, let's look at part B. Mariah's going to read for us.
If the vector b equals 3, 7 is sketched with the initial point of 2, 4, what is its terminal point?
All right, so we're finding its terminal point now. All right. Well, it tells me what my vector ends up being. My vector ends up being 3, 7, right? And it also gives me my initial point of 2, 4. Well, how did 3, 7 end up happening? Because it's always what? Terminal minus the initial. Which one do I need to find? I need to find the terminal. And so to do that, if we kind of go backwards, I don't know what my terminal is, so I'm just going to call it x, minus, what did I get? What was I given? 2. Comma, I don't know my y of my terminal, minus the 4. All right? And so if I set them equal, I set x minus 2 equal to 3, because that's what it ends up being, right? And then I'd set y minus 4 is equal to 7. Well, x would equal what? 5. And y would equal 11. So my terminal point is what? 5, 11. All right. So you kind of have to work backwards a little bit. What if they gave me my terminal and they didn't give me my initial? Then it would be like 2 minus x. You following me? Or then 4 minus y. Okay, so it would be kind of just flipped a little bit. All right, pretty good? It's always what? Terminal minus the initial. You try this one. How do I find vector v?
So you do parentheses, 4 minus -1.
No. The other way. Why is it the other way? Terminal minus the initial. So my terminal is -1 minus 4, comma 5 minus -7. All right. So what is my vector v? -5, comma 12. All right. Now let's talk about what that really did. What did that vector do? It went left 5 and what? Up 12. All right. So it went left and up. All right. All right. So now let's talk about its magnitude. So I notate its magnitude by two absolute value bars looking thing. All right. So my magnitude of v is just the difference of my x's. So what's the difference of my x's? 5. So I have 5 squared plus 12 squared. And so I have square root of 169, which is 13. So my magnitude of vector v is 13. All the magnitude really is it's the hypotenuse of the vector. All right. If these kind of are notating how you go left or left 5 and then up 12. The hypotenuse would be 13. That's really what's happening. Okay?
Yes.
All right. So now we're going to talk about how these vectors are actually adding or subtracting to one another. All right. If I have two vectors, if I have a u vector and a v vector, and I add them together, all I do is add their parts. So I just do like the x's added together, comma the y's added together. Follow me? If I have to subtract them, I do the x's subtracted from each other, the y's subtracted from each other, right? Then if you have to multiply, it's called a scalar multiple. Now, you guys did this in geometry. What was this called in geometry? Does anybody remember? Starts with a D. You have it done to your eyes. The dilation. Okay, that just means it gets bigger or smaller of that vector. When you multiply, that's what's a scalar multiple of it. Now, I need to talk about how you actually add them, and you can write this out as however you want. If I have a u vector and I have a v vector like this, if I add them together, wherever I end up, that's where I start again. All right? Some mathematicians call it head to tail. They call this the head, this the tail. So, you draw it, and then you put the tail on it, and then you draw it again. All right? So your terminals and your initials have to be together. Your terminals can't be the same. So like two heads can't be together. Two butts can't be together. All right? Two tails. All right? So that's how you add them together. And then this thing right here is called a resultant. All right? So what you actually end up with is called a resultant. I'd like you to write that word down. Okay, a resultant is what you actually get as a result of doing it, of adding or subtracting or multiplying, whatever you're going to be doing. Okay, that's called the resultant vector. All right, write this one out. I have vector v is -2, 5, and vector w is 3, 4. We're going to go back to 7th grade math at the beginning. All right. So, first of all, what's vector v doing? It moves which way? Left and up. And vector w moves what? Right and up. All right. So on this first one, I have 2 times vector v. And all we're going to do is we're going to do 2 times the vector, -2, 5. And so we're just kind of going to use that distributive property. So guess what I would have for 2 times the vector of v? -4, 10. All right. Doesn't that make sense? If I double it, I'm going to go double. All right. Let's look at part B. All right. I have w, vector w minus vector v. So I'm going to have vector w, that's 3, 4, minus vector v, negative 2 comma 5. All right. So I'm going to subtract them now. So now my x component of my vector is 3 minus a negative 2, which is what? 5. And then 4 minus 5, which was negative 1. So my resultant vector ends up being 5 comma negative 1. All right. I'm going to graph that one with you. You're going to be asked to graph occasionally, so let's do it together. All right. So draw out a little grid. Doesn't have to be perfect. All right. And then we're going to graph it. So the first one we're going to graph is W. Okay, vector W, because that's what we started with. Are you following me? So vector W does what? It moves which way? It moves right 3 and up 4. So we go right 3, and then we go up 4. So that is my vector W. Are you following me? Is that good? All right. And then it says minus vector V. Well, vector V normally goes which way? Usually goes left and up. But if I'm subtracting it, it does the backwards thing. All right? Instead of going left and up, now which way is it going to go? It's going to go right and down. We're going to change the signs on it. Are you following? All right? So if I have to subtract that vector, now I'm going to go right 2, and then I'm going to go down 5. So 1, 2, 3, 4, 5. And so my negative vector V goes something like that. All right? And then when I connect my original initial to my final terminal, that is my W minus V vector called the resultant. All right? And guess where that resultant ended up? Five comma negative 1. See how that works? All right? So if you do it correctly, you'll make a little triangle, and you'll end up getting the result in what your math did. The math's a little easier than the graphing, probably. Yes, Maria?
I thought you said there were supposed to be like 2 arrows connected.
This is the resultant vector.
So that doesn't matter.
That's going to go from your initial, the origin usually, to wherever the last one ends up. Okay? But when you're connecting there, it shouldn't. Okay? All right, good question. Hi there.
Why did you have to start in position in P going off of W again?
Because that's where we have to start it. Okay? Yep. Mathematicians usually call it head to tail, head to tail. All right? All right. Okay, but it's really like your initial has to start at the last terminal. Okay? All right, let's look at part C. So now I have vector V plus 2 times vector W. So my vector V is negative 2 comma 5 plus 2 times vector W. Now, order of operations still matter. So what do I have to do first? I have to multiply by 2. So when I do that, I end up getting 6 comma 8. All right. And then I still have negative 2 comma 5. And so now I just have to add them together. So what is my resultant going to be? 4 comma 13. All right. So if I actually add up all those 3 vectors that it told me, because this is really 2 times that vector, my resultant should be a 4 comma 13. Which way does that go? To the right and up. All right. All right. Worksheet 6.3a. Worksheet 6.3a.